Now let's have a look at the sketch. So here's a sketch. You can get the sketch from the course's GitHub repository right here. And if you're copying straight from here, remember to use the raw representation, the raw version of the sketch so that you don't copy any formatting information across to your Arduino IDE. So here's a sketch. It's very simple. No third-party libraries are required. Start at lines 45 to 50 where I define the latch, clock and data pins. You can have those connected to any available digital pins. They don't need to be connected to 9, 10 and 8. Then inside the setup function, we turn those pins into outputs. And the purpose of this demonstration, just to show how the 595 shift register works, is to simply produce a random pattern on the LEDs. And luckily, the Arduino IDE comes with a function called random. Actually, I should show you down here. There it is. This is where we are actually grabbing or generating a random number between 0 and 255. But to properly use this function, we need to grab a random seed number. So we use the random seed function to do that. And we just need to pass a parameter that is essentially noise. So the more random the number that we pass to random seed is, the more random the number that we generate with the random function will be. So because right now analog pin 0 on my Arduino is not connected to anything and is configured by default to be an input, its value is floating and is completely undeterminable. So it is a very good way to grab a random seed number from the environment. So that's what we do here in line 57. We seed the random number generator in the Arduino IDE. Then inside the loop, again and again, we generate a random number from 0 to 255. And I used decimal 255 because I just want a single byte to be returned from this function. That's why the data type of variable rand number 1 is a byte, which contains 8 bits, which is how many LEDs we've got in this circuit. And once we do that, we pass this number to the right LEDs variable, which is down here. So we pass this byte to right LEDs. We give it a new local name called pattern. And then remember what we said earlier in regards to how to pass or how to update the memory of a shift register. First, we take the latch and we bring it down to low. Then we update the contents of the memory of the shift register. To do that, we use the function shift out, which is built into the Arduino IDE. So there's our data pin, there's our clock pin, and then we just pass the pattern. What this represents is the fact that we are sending the most significant bit of the byte first. We could have done LSB, which means the least significant bit of the pattern. So in this case, since we are playing around with random numbers, it doesn't really matter at all. And once we shift out our 8 bits or the complete byte, we go ahead and we bring the latch back to high in order to update the output of the shift register. So it's fairly simple. Let's try that and see what it does. I'm going to connect it to my Arduino. And there you go. I've already uploaded the sketch and you can see that the LEDs are blinking completely randomly. Now, let's see how easy it is to double the number of LEDs that we are controlling with the addition of a second shift register, but without making any changes on the Arduino side of the circuit. We'll do that in the next lecture. Thanks for watching. If you'd like to learn more, check out my Arduino Step-by-Step Getting Started and Arduino Step-by-Step Getting Serious courses on the Tech Explorations School. There, I help you develop basic and more advanced Arduino skills, including how to write your own programs, how to use all sorts of sensors and actuators, and how to create your own gadgets. You may also be interested in my project courses, where you get deep into the development of wheeled robots, remote-controlled cars, and drones. Please use the coupon code in the description below this video to get a YouTube exclusive discount to my courses. See you there.